This is an example covering the goodness of fit test. When you have more than two proportion in a problem, then you know that you will need a goodness of fit test. As you notice at first glance, when you look at this exercise, there are several percentages, 1, 2, 3, 4, 5, 6, so more than 2. It's going to be a goodness of fit example. Let's read it. The national distribution of fatal work injuries in a country is shown in the table to the right under national percentage. You believe that the distribution of fatal work injuries is different in the western part of the country and randomly select 6,231 fatal work injuries occurring in that region. At alpha equal 10%, can you conclude that the distribution of fatal work injuries in the West is different from the one that's given to us? Here's how we state the null in the alternative hypothesis, and you do it always that way. Your null hypothesis should be the distribution is as given to us, is as claimed. Here it's a distribution of fatal work injury, so we just write distribution of fatal work injury is as claimed, or is as given, or is as stated, or is as expected. You can use this language, that should be fine. Your null alternative hypothesis should be that the distribution is not as claimed, is not as stated, is not as expected, is different from expected. So as long as you put it, just in the spirit of this language, then you should be correct. Distribution of fatal work injuries is different than expected, the expected distribution. And you agree with me that should be the claim, because he says, can you conclude that the distribution of fatal work injuries in the West is different? So that's what we have the word different here. So we surveyed 6,000, we went to the record and looked at 6,231 fatal work injuries, and we found out that 2,887 of them were transportation, 1161 equipment. Those numbers that are given to us right here are called the observed values. We're going to be using StatCrunch to find the test statistic, which is a chi-square test, and the p-value. So the numbers that are given to you here are called the observed values. All the frequencies usually in the table are called the observed values. The test statistic will require two types of values. One are the observed values, and one are called the expected values if the distribution was as claimed. And the expected values are the percentages, but they're going to be percentages of the total. So you're going to input, those values, but not as percentages, as number. So what you're going to do, just to find the expected value for transportation, you're going to take 44% and multiply by the total, which is 6231. You're going to take 17% and multiply by 6231. You're going to take 14% and multiply by 6231. So even guys, you're using technology, you still have to do this part of work manually using a scientific calculator to get those numbers. And I'm going to show you now how to use StatCrunch, to do this. So we know how to find the expected values, which we're going to do it shortly. This is the test statistic. That's the formula. It's a chi-square distribution. It says it's sum of O minus E squared divided by E. O means observed and E means expected. And the observed values, as you know, these are the O's, and the E's, we have to calculate them. These are the percentages that we need in order to compute the E's. So if you are to do the test statistic by hand, it's a lot of work. You have to find all the E's. You have to subtract each E from each O and square them, and then you have to divide, the difference by E, and then you have to add them up. But StatCrunch can do it all in one shot. Let me take you to StatCrunch and show you how to do the rest. So I input the observed values under variable 4, but look what I like you to do here. So when you use StatCrunch, it will be straightforward. Where you put the frequencies, the observed value, change the name to variable 4, change it to observed. And here they're going to be the percentages of the total. I just put them here to show you how we're going to calculate those using a scientific calculator. But to change the name here and call it expected. Now go to a scientific calculator and try to multiply 0.44 times 6231. And then multiply 0.17 times 6231, 0.14 times 6231, 0.13 times 6. You will get those values. I just did the math and I'm going to share it with you right here. This is what I got. So if you multiply them, these are called the expected values. How do you run the test for the goodness of fit? You go to stat, goodness of fit, chi-square test. Okay, let's do that a little bit. I want you to see the entire screen. Observed, select column. You see, because you name it observed, it's easy now. You just select observed. Expected, select column. Expected, and display expected, compute. And let me show you the results. Here you go. So the chi-square test. The chi-square test statistic is 72.141. And the p-value is so small that it says less than 0.001. So let's write them down. So chi-square is 72.141. The p-value is almost 0. You can write 0.000, which is less than alpha. And because this is less than alpha, guys, you can reject the null hypothesis. Alpha is 10% in this exercise. And if you reject the null hypothesis and the claim is in the alternative hypothesis, you support the claim. So there is enough evidence at the 10% level of significance to conclude that the distribution of fatal work injuries in the West is different from the national distribution. And this is the language that I picked here. There is enough evidence to conclude that the distribution of fatal work injuries in the West is different from the national distribution. So this is how you perform a goodness of fit test.